Geometric sequences. On Friday we talked about arithmetic sequences, sequences of numbers where you add the same thing each time. Geometric sequences, sequences of numbers where you multiply by the same thing each time. Again, I took a page from the book here. Geometric sequence with a starting value a and a common ratio. We have a similar situation here. On Friday, in those sequences, you add the same thing each time, and we had a number d that we called the common difference. And if you recall, we called it the common difference, even though you add the same thing each time, because if you took any term in the sequence and subtracted the term right before it, you would have gotten the common difference. Whereas in a geometric sequence, if you take any term in the sequence and divide by the term right before it, you are going to get r, and we call this the common ratio. That's why we're multiplying by the same thing each time, but we call this value r the common ratio, ratio meaning divide. Again, there is a recursive formula here, which we're going to say is less useful. We're going to focus on the explicit formula right there. This is going to become useful. I do not want anybody in a few minutes to be asking, where did you get that? That is what I will be using. That is the explicit definition for a geometric sequence. Is the sequence geometric? If it is, what are A and R? So, in part A, if I take the second term and divide by the first term, is that the same as if I take the third term and divide by the second term? No. This would be 2. This would be 5. Is 2 equal to 5? Sure isn't. Part B. If I do the same thing, second term divided by first, is that equal to third term divided by second? This gives me negative 3/5. Is that equal to, what is negative 3.6 divided by 6?
Which is negative 3/5.
Yeah. So yes, that one is geometric. What are A and R? And again, when the book says A, what they're meaning is the first term. What is the first term of the sequence in part B? It is negative 10. What is R? R is negative 3/5. When you do this to make sure they're the same, what we did there was made sure that the common ratio was common, and that is R. So then they don't ask for it here, but what is the explicit formula? The explicit formula for the nth term of this sequence is given by the first term, negative 10, times R to the n minus 1. What are the second and third terms of the geometric sequence? 2 blank blank 128. So what do we know about this situation? We know that the first term is 2. We know that the fourth term is 128. And we know that it's a geometric sequence, so we multiply by the same thing each time. Using the explicit formula for a geometric sequence, 128 should be 2 times r to the 4 minus 1, which is 2r cubed. Because 128 is the fourth term. So now we just want to find out what r is. Divide each side by 2. We get 64 is r cubed. So the cubed root of 64 is r, which is 4. So we know what the common ratio is. So what are the two blanks? 2 times 4 is 8, times 4 is 32, which I believe this was actually part of the homework in section 9.1 that we just turned in. There was a sequence that was that exact sequence, actually. You work as a store manager and need to clear some inventory. You decide to discount each item by 30% of the previous week's price until the entire inventory is sold. The original price of one item was $60. What will be the cost of the item during the 5th week of the sale? So, in the first week, okay, the original price was 60. What is the common ratio in this problem? 0.7. You have to remember that they're being discounted by 30%, which means you're going to have 70% left. The trick here is, in the first week of the sale, what is the price? 42. So the price in the first week of the sale is actually the second term in the sequence. So we're not looking for the 5th term. We are looking for the 6th term. So that's 60 times 0.7 to the 6 minus 1, which is 10.08. So what will be the cost of the item during the 5th week of the sale? $10.08. Last problem. What are the possible values of the missing term of the geometric sequence 28 blank 7? This is where we get to talk about the geometric mean. Friday we talked about this as an arithmetic mean, and we actually found it when there was one missing term by using the formula we all knew for arithmetic mean, otherwise known as average. Now last year in the geometry, you should have learned about geometric mean as it relates to some specific right triangles. Does anybody remember the formula for the geometric mean of two numbers? If I have two numbers x and y, the geometric mean is the square root of x times y. So in the problem above, what is the geometric mean of 28 and 7? It is going to be the square root of 28 times 7, which is what? 14. But the trick here is, that's the square root of 196, isn't it? Could I say that's negative 14? Yes. So we have 28 blank 7. That blank could be 14, or it could be negative 14. Either way, you could do a little plus or minus action there. But either way, it's a geometric sequence. In this case, we go times 1/2 times 1/2. If it were negative 14 instead, it's times negative 1/2 times negative 1/2. So, long story short, if you have a problem like this, where you have missing terms in a geometric sequence, if there is an odd number of missing terms, and in the homework you're only going to have to worry about one missing term or 3, but if there's an odd number of missing terms, you're going to have to worry about this plus or minus situation. If there's an even number of missing terms, like in our previous problem, you don't have to worry about it. Let's look at that. Number 5 on the 9.2 worksheet. We know the first term is 20. We know the common difference is 2. So the explicit formula, an, is 20 plus n minus 1 times 2. So to find the 52nd term, it is 20 plus 52 minus 1 times 2, which is 20 plus 102. which is 122. So to find the 50-second term, you just have to use the explicit formula, which is nice. That's why I asked for, in those problems, the 50-second term and the explicit formula, because to find the 50-second term, you have to have the explicit formula anyway, so you do both of those regardless.